गाना था
जन्नी बोल लगा ना
जो थकना गाय दिते জল দিতে ভালো লাগছে লাগে
Hello everyone, how are you all?
I'm good, sir. How about you?
Also good, thanks for asking. And how's the exam preparation? कल exam है ना?
Yes, sir.
कैसा preparation है बताओ, इस बार तो सब आ रहा है।
ठीक ठाक ही है सर।
चलो तुम तो कर लोगे भाई, बाकियों का? बाकी भाइयों कैसा है? यार तुम्हारा ये प्रॉब्लम है कि तुम लोग मुझसे कोई शायद रिस्पॉन्स करना ही नहीं चाहता, ना क्लास में करते हो ना और कुछ। चलो एक्चुअली आई वाज रॉन्ग at some point that yeah, today will be the last DSA class. One topic is remaining, that is backtracking. We will be covering that probably on Monday. Okay, not so yeah, fairly difficult topic, but yeah, we'll cover that on Monday. So that will be our last DSA class. I just recalled it that yeah, backtracking is left and we will be covering that on Monday. Again, full of recursion, backtracking. Today we will see quickly some important graph topics. That is, first is BFS and that is shortest path algorithm. Okay, chalo 14 participants only. Shall I wait for 2-3 minutes more? Kare आ जाने दो।
Yes, sir. कम करते हैं सबको।
कर लेते हैं थोड़ा और वेट। चलो, और एक ही हफ्ता है ऑलमोस्ट हमारा करिकुलम। जैसे जैसे दिन आगे जा रहे हैं हमारा करिकुलम आगे बढ़ते जा रहा है।
टाइम का तो सर पता ही नहीं चला।
तुम लोगों को पता नहीं चल रहा होगा, पर मेरे लिए तो 3 months लॉन्ग टाइम है। सीरियसली फर्स्ट टाइम मैंने कभी मतलब इतना लॉन्ग किसी बैच के साथ बिताया है। बहुत जन नए आए, बहुत जन फिर बैच चेंज करके चले गए प्रीवियस बैचेस में, लाइक जाजिब सर वाले में। कौन कौन गया है जाजिब वाले सर में, जाजिब सर वाले क्लास में हमारे बैच से?
पता नहीं सर, एक दो के मैसेज पड़े हैं बस।
एक शायद अमर गया है, एक शायद अमीनुल गया है ना, पहले स्टार्टिंग में था हमारे साथ। या फेयरली 51 स्टूडेंट्स थे ऑलमोस्ट, 51 स्टूडेंट्स थे ऑलमोस्ट। अभी कितने हैं? 38 हैं। तब काफी ना बैच चेंज, एटलीस्ट 6-7 ने बैच चेंज किया होगा as far as what I am able to recall. चलो सही, आप सबके साथ इतना दूर मैं खींच पाया, मैं आ पाया, यही बात है। हमारा पेस क्वाइट स्लो था स्टार्टिंग में, दैट्स व्हाई इतना दूर दिसंबर के, मतलब मान लो अगर प्रोजेक्ट होता है तो ऑलमोस्ट दिसंबर 17 तक तुम्हारा बैच जाएगा इफ प्रोजेक्ट हैपेंस।
इसके बाद ही प्रोजेक्ट होगा?
यस, इसके बाद ही अगर कुछ प्रोजेक्ट होता है। लेट मी ग्रैब द इंफॉर्मेशन वेदर प्रोजेक्ट्स विल बी देयर फॉर यू और डायरेक्टली प्रोजेक्ट आपके फुल स्टैक के बाद होगा। सीख लो ये, ठीक है, फुल स्टैक अच्छे से, बिकॉज recently I appeared for Microsoft interview and they also asked me whether मैंने REST APIs फ्रंट एंड वगैरह में कभी काम किया है या नहीं, ठीक है। fairly nice experience was it। और कुछ कुछ ऐसे भी इंटरव्यूज हो सकते हैं आप सबको मिले जो मतलब टेक्नोलॉजी, आपको आपसे टेक्नोलॉजी ज्यादा पूछे। लाइकवाइज बताता हूँ, अमेजोन जाओ, इंटूइट जाओ, एटलासियन, ये सब कंपनीज में अप्लाई करोगे, डीएसए के बगैर ज्यादा कुछ पूछता नहीं है। तो जिनका ग्रिप डीएसए पे बहुत अच्छा है, अमेजोन वगैरह जाना आसान हो जाता है।
I do Amazon, Facebook.
फेसबुक इज फुल्ली बेस्ड ऑन लीड कोड। फेसबुक इंटरव्यू इज फुल्ली बेस्ड ऑन लीड कोड। वो लोग क्या करते हैं ना, डायरेक्ट लीड कोड से क्वेश्चन उठा के तुम्हें दे देते हैं कि करो ये सॉल्व करो,
ओके।
ठीक है। बट फेसबुक निकालना, फेसबुक खैर इंडिया में तो पता नहीं पोस्ट मतलब किनको लेते हैं, बट बाहर फेसबुक का मेन ऑफिस जो है रिक्रूटमेंट बाहर ही होता है। लंदन ऑफिस में जैसे अभी एक्टिव हायरिंग हो रही है, बहुत ज्यादा हायरिंग हो रही है।
ओके।
सुनो, अगर किसी को प्रोडक्ट बेस्ड में जाना है, सबसे फर्स्ट टारगेट अमेजोन रखना। अमंग ऑल प्रोडक्ट बेस्ड अमेजोन निकालना सबसे आसान है, ठीक है। अमेजोन निकालना सबसे आसान है। और ये मत सोचना फर्स्टली तुम जाओगे तो तुमसे रिएक्ट पूछेगा, ये पूछेगा, वो पूछेगा। हार्डली कोई पूछता है, बहुत मिनिमम लेवल पे, अनलेस एंड अनटिल यू आर गोइंग फॉर SDE2। वो भी नहीं, SDE2 में भी कोई रिएक्ट एंगुलर नहीं पूछेगा वहां पे। डीएसए होगा, डीएसए पूछेगा, 1 2 3 राउंड डीएसए तो जाएगा ही। योर डीएसए शुड बी वेरी स्ट्रांग। जितना स्टैंडर्ड एल्गोरिथम्स हमने अभी पढ़ा सबके बेसिस पे एटलीस्ट 10 to 15 प्रॉब्लम सब कर लो स्टैंडर्ड इंटरव्यूज का। और सिस्टम डिजाइन बहुत अच्छा रखना पड़ेगा। SDE1 के लिए उतना सिस्टम डिजाइन नहीं पूछता है फर्स्टली। SDE1 फ्रेशर हो, एक्सपीरियंस नहीं है तो कोई सिस्टम डिजाइन नहीं पूछा जाएगा। एक्सपीरियंस, वंस यू आर एक्सपीरियंस्ड यू शुड बी नोइंग विथ सिस्टम डिजाइन कॉन्सेप्ट्स। जितना मेरा एक्सपीरियंस है उस बेसिस पे मैं बता रहा हूँ, सिस्टम डिजाइन एंड डिजाइन पैटर्न शुड बी वेरी स्ट्रॉन्ग इफ यू आर अप्लाइंग फॉर SDE2। SDE1 के लिए उतना नहीं देखते। And yeah, for Microsoft also your educational background doesn't matter. This is what I have gathered the information.
मैटर नहीं करता?
नहीं करता। मुझे जो इंटरव्यूअर ने बताया कि नहीं, हम उतना नहीं देखते कि आप किस बैकग्राउंड से आ रहे हो। यस, पर ये जरूर देखते हैं तुम्हारा प्रोफाइल क्या है। सिंस कि मेरा कॉम्पिटिटिव प्रोग्रामिंग में कुछ अच्छा प्रोफाइल था, डिस्प्ले करने को बहुत चीजें थी, दैट्स व्हाई एक।
अच्छा, एक क्वेश्चन मेरे को पूछना था।
बताओ।
जैसे आप लोग जो मतलब अभी भी शायद आप लोग इस पे लीड कोड पे वगैरह प्रैक्टिस करते हो शायद।
मैं करता हूँ तो मुझे अगर करना होता है मैं कोडशेप पे ज्यादा टाइम बिताता हूँ।
हाँ, जो भी मतलब जो भी प्लेटफॉर्म यूज कर रहे हो, तो उस पे आप जो डेली पोस्ट करते हो तो उसमें कुछ ऐसा भी आता है कि जिसका आंसर गलत आ रहा है?
एज इन क्या आंसर गलत आ रहा है? मतलब मैं जो सबमिट कर रहा हूँ आंसर।
हाँ हाँ।
हाँ, कितने को आता होगा?
तो उससे क्या इफेक्ट आता है प्रोफाइल
कुछ
पे?
नहीं आता।
कोई फर्क नहीं पड़ता?
अगर कॉन्टेस्ट में खराब रैंकिंग आई तो आएगा। कॉन्टेस्ट कर रहे हो 3 घंटे का, लॉन्ग चैलेंजेस कर रहे हो, उससे खराब रेटिंग खराब आती है, ठीक है। तो उसमें प्रोफाइल का जो स्टार्स है वो कम जाता है, कमता बढ़ता रहता है, समथिंग लाइक दैट हैपेंस।
डेली प्रैक्टिस में नहीं होता
ना, डेली प्रैक्टिस में नहीं होता। बट स्टिल कॉन्टेस्ट करना जरूरी है। दिस इज व्हाट आई विल से।
कल मैंने एक पर्सन का प्रोफाइल देख रहा था, तो उसमें यानी बहुत सारे कोड्स उसने सबमिट किए हैं, वो एक्सेप्टेड है, और बहुत सारे का रॉन्ग आंसर है। तो मैं सोचा कि
रॉन्ग आंसर आता डजंट मीन कि तुम्हारा खत्म हो गया बात वहीं पे। रॉन्ग आंसर आ रहा है तो उसका एडिटोरियल पढ़ो, कैसे सॉल्व हुआ है।
ओके,
ठीक है, दिस इज द वे। ये हमने भी किया है, एडिटोरियल्स पढ़े हैं, क्वेश्चन का अप्रोच देखा है क्या हो रहा है।
तो फिर मैंने उनसे बात की, तो वो बोले कि पहले आप लीड कोड पे मत आओ, पहले आप हैकर रैंक ट्राई करो।
हाँ, बात सही बोला। पहले हैकर रैंक ही ट्राई करो, मैं भी रिकमेंड करता हूँ। पहले डायरेक्टली लीड कोड में जंप मत किया करो।
हाँ, आप
और
लीड कोड पे प्रोफाइल्स वगैरह मत देखो, और आप पहले
प्रोफाइल देख
पे
के क्या
जाओ।
होगा, बस अपना डिसेंट परफॉर्मेंस रखो, अपनी तरफ से
हम्म,
अच्छा प्रैक्टिस रखो। फर्स्टली सिंस यू आर फ्रेशर्स, जितने इंटरव्यू स्पेसिफिक प्रॉब्लम्स है सबको सॉल्व करो।
ओके।
ठीक है, पहले वो करो, उसके बाद सीपी की तरफ जाना अगर शौक है तो, कि मुझे और करना है। ठीक है, तब सीपी जाना है। सीपी में सोचना पड़ता है, स्टैंडर्ड नहीं मिलता, कुछ अनयूजुअल प्रॉब्लम्स मिलते हैं वहां पे,
बट
सोचना
बट
पड़ता है बैठ के।
जितने भी प्रोफाइल्स मैंने कल सर्च किए, ये लोग सब लोग C++ में कर रहे हैं।
सी प्लस प्लस बहुत फेमस लैंग्वेज है ना ये सब
हाँ।
करने के लिए। सी प्लस प्लस का एक ही एडवांटेज है, बाकी कोई भी लैंग्वेज हो उससे सी प्लस प्लस बहुत ज्यादा फास्ट है।
ओके।
द एडवांटेज ऑफ सी प्लस प्लस इज लेट इट बी एनी लैंग्वेज। पाइथन बहुत पावरफुल है इन ए सेंस, पाइथन की लाइब्रेरीज बहुत है, कुछ भी कर सकते हो पाइथन से, वेब डेवलपमेंट कर सकते हो, यूआई बना सकते हो, सिस्टम सॉफ्टवेयर बना सकते हो, एप्लीकेशन बना सकते हो, डेटा साइंस कर सकते हो, मशीन लर्निंग कर सकते हो, वॉट एवर यू वांट टू डू यू कैन डू इट यूजिंग पाइथन। पाइथन हैज दैट एडवांटेज, बट पाइथन इज स्लो, पाइथन इज इंटरप्रेटेड लैंग्वेज दैट इज वेरी स्लो। अगर यही लाइब्रेरी का फैसिलिटी सी प्लस प्लस में डाल दो, सी प्लस प्लस से अच्छा लैंग्वेज नहीं हो सकता, उतना
तो
लाइब्रेरी
फिर
सी प्लस प्लस में
हम
आते
लोग
नहीं।
तो फिर हम लोगों को सी क्यों नहीं बोला पढ़ने के लिए?
सी सीखने जाओगे तो बहुत टाइम लगेगा,
ओके।
लैंग्वेज सीखने में ही सी समझ में तो आएगा नहीं, स्टार्टिंग स्टार्टिंग में समझने में बहुत दिक्कत होता है सी लैंग्वेज। ओके, लैंग्वेज सीखने में बहुत टाइम जाएगा।
तो
ठीक
साइड
है,
बाय साइड हमने C++ का प्रैक्टिस करना चाहिए क्या?
नहीं बिल्कुल नहीं, लैंग्वेज कोई भी हो उससे मैटर नहीं करता।
ओके।
ठीक है, सारे जो प्लेटफॉर्म्स है उसमें लैंग्वेज के लिए डिफरेंट डिफरेंट टाइम लिमिट्स होता है, मतलब अपने हिसाब से एडजस्टेड रहता है। वो तुम लोग को उतना मत सोचो, कोई भी एक लैंग्वेज पकड़ लो, लैंग्वेज का बेसिक्स जान लो, लैंग्वेज के ऊपर ग्रिप लाओ और उसी में प्रैक्टिस करो, प्रैक्टिस करते करते ग्रिप भी बढ़ेगा।
ओके।
ठीक है, मैं जब सी प्लस प्लस में करता था, मैं आई नेवर थॉट मुझे पाइथन करना है। ठीक है, मैं कभी सोचा ही नहीं। वंस मेरा सी प्लस प्लस में ग्रिप बढ़ गया, मेरे लिए पाइथन करना कोई बात ही नहीं थी। दिस इज द रूल, वंस मैं इसको अच्छे से जानता हूँ, मेरे लिए ये सीखना कोई बात ही नहीं है। दैट्स ऑल।
और सर, फाइनल राउंड्स में कम्युनिकेशन बहुत मैटर करता है क्या?
टू सम एक्सटेंट मैटर करता है, कम्युनिकेशन तुम कैसे कर रहे हो।
हाँ।
वो उनको वो लोग देखते हैं, जैसे गूगल में मुझे फीडबैक मिला था एक, कि यार तुम्हारा कम्युनिकेशन बहुत अच्छा है, मुझे बोला था गूगल की तरफ से। ये मुझे एक
ओके।
फीडबैक मिला था उनकी तरफ से कि यार तुमने जो भी सॉल्यूशन किया, यू कम्युनिकेटेड दैट वेरी इफेक्टिवली।
ओके।
इट डज मैटर, अगर कोई फिर भी अगर तुम अच्छे से कर पा रहे हो तो शायद कम्युनिकेशन उतना फैक्टर ना रखे, बट स्टिल अपना कम्युनिकेशन सुधारना पड़ेगा सबको। अगर मानते हो कि मेरे से नहीं हो रहा है तो डू अ
हाँ,
प्रैक्टिस ओवर
मुझे
दैट
मुझे
आल्सो।
दिक्कत है मतलब पता सब है मुझे कि ये हो कैसे रहा है, क्या कर रहा है, कैसे हो रहा है, बट जब एक्सप्लेन करने जाता हूँ तो थोड़ा सा दिक्कत होता है।
ठीक है, तो कर लो सही से, मॉक देते देते सब सही हो जाएगा। पर ये स्टार्टअप्स में उतना दिक्कत की बात नहीं है। ठीक है, स्टार्टअप्स में जाना है अगर, तो ये कम्युनिकेशन उतना फैक्टर नहीं है। स्टार्टअप्स में देखता है मेनली स्किल्स है, बस हो गया, स्किल्स है तुम डेमोन्स्ट्रेट कर पाओ, इंटरव्यू में डेमोन्स्ट्रेट कर पाए, अगर कर पाओगे तो पक्का श्योर हायरिंग हो जाएगी। स्टार्टअप्स में यही देखता है, स्टार्टअप्स में मैटर है, स्टार्टिंग में काम बहुत करना पड़ता है भाई।
नहीं, काम करने से नहीं डरते सर हम।
दैट्स फाइन, स्टार्टअप बहुत, अगर देखो, इफ somebody can work very much, वर्कaholic हो, अल्कोहलिक नाम सुना है ना, तो
यस।
वर्कaholic हो तो स्टार्टअप्स जाओ, सब स्टार्टअप्स इज फॉर यू।
ओके।
फाइन, या फिर एज ए करियर की बिगिनिंग है, करियर की स्टार्टिंग है, तो भी स्टार्टअप जा सकते हो।
ओके।
ये जो लर्निंग कहते हैं ना,
हम्म।
लर्निंग ग्रोथ, अगर स्टार्टअप अच्छा मिलता है, लर्निंग का जो कर्व होता है बहुत फास्ट होता है स्टार्टअप्स में, बहुत तरह की चीज सीखने को मिलती है ये कहते हुए तो। ठीक है, मैंने मेरे दोस्तों ने भी कहा, मेरे दोस्तों से भी जो मैंने सुना है, एज वेल एज मेरे एक सीनियर ने भी कहा है, तो एज पर देयर रिव्यू, मैंने तो वही सुना है आज तक, स्टार्टअप्स में लर्निंग कर्व हाई होता है। अगर किसी को बहुत सारी चीजें सीखनी है, इफ समबडी लर्न्स दैट शॉर्ट टाइम में मैं बहुत चीज सीखूं, स्टार्टअप्स जाओ, क्योंकि जब एमएनसी जाओगे ना, एमएनसी में एक ही चीज
स्पेसिफिक
सीखोगे,
काम रहेगा।
स्पेसिफिक चीज सीखोगे, वो उसी के अंदर डेप्थ आएगा। ठीक है,
हाँ।
उसके अंदर बहुत डीप में काम करना पड़ेगा, और ये जो प्रोजेक्ट कर रहे हो ये लॉन्ग टर्म प्रोजेक्ट होता है,
हम्म।
लॉन्ग टर्म होता है, ये एक एडवांटेज रहता है, इससे वर्क लाइफ बैलेंस बहुत अच्छा मिलता है, ये भी एक एडवांटेज है। ठीक, और कोई
बट
चार?
ग्रोथ करना है तो स्टार्टअप इज बेस्ट।
नो, नथिंग एज सच। ग्रोथ तुम्हारा पर्सपेक्टिव है, तुम्हें कैसा
नहीं,
ग्रोथ चाहिए? डीप
हाँ
डेप्थ चाहिए
कोई,
किसी जगह पे, या फिर बहुत सारी चीजें सीखनी है?
हाँ
बहुत सारी सारी चीज सीखनी है, स्टार्टअप्स चाहो। डेप्थ चाहिए, किसी एमएनसी में काम करो, यही बात है।
ओके।
अब ऐसा नहीं स्टार्टअप्स में डेप्थ नहीं मिलता, वहां पे भी मिलता है बहुत, मतलब बट हाईली डिपेंड्स इन विच स्टार्टअप यू आर वर्किंग। अब ऐसा नहीं कि तुम किसी एडटेक स्टार्टअप में जाके पढ़ाने लग गए, ठीक है। खैर
ओके।
छोड़ो, हो गया डिस्कशन इतना सारा। लेट्स स्टार्ट विद बीएफएस टुडे। 20 पार्टिसिपेंट्स हैव अराइव्ड। अच्छा पहले बताओ, डीएफएस सबको ठीक लगा? मतलब ऑल ऑफ यू आर फाइन, गुड विद डीएफएस, अंडरस्टूड दैट?
हाँ समझ में आया, और थोड़ा सा समझने की जरूरत है।
ओके फाइन, ठीक है, टाइम ले लो बिकॉज कल तो चलो खैर एग्जाम है।
हाँ कल तो क्लास में रहेगा।
ओके फाइन, let's start with BFS. Okay, let me draw a graph.
ओके।
अगर स्टिल प्रॉब्लम होता है, डाउट क्लास में विल कवर दैट कि BFS में क्या प्रॉब्लम हो रहा है, ठीक है?
यस सर।
ओके, लेट्स स्टार्ट हियर। ओके, टेल मी, बताओ लेवल, somebody tell me what is the depth? What is the depth? If one is my start point of graph, what is the depth, respective depth of all nodes?
1 2 4 3
1 2
डेप्थ बताओ, सर्च मत बताओ, डेप्थ क्या है? 1 का डेप्थ क्या है, 2 का डेप्थ, 3 का डेप्थ,
0
4 का डेप्थ? Depth of 1, this node, the start point will
0
always be 0. 2 3
1
1
1 and 4.
2
2
Is it? How many of you agree with Saurabh and Junaid? How many of you agree with Junaid and Saurabh that okay, 1 is the starting point, it lies at depth 0. 2 3, node 2 and 3 lies at depth 1, and node 4 lies at depth 2. What BFS tell me? Full form of BFS is breadth first search. Breadth first search. What happens here? Rather than going to the depth, rather than going in depth and searching for nodes, what we will do, we will explore all the nodes present at the same depth at one go. How we will do that? Once I am at depth 0, right now I am at depth 0 because my start point is at depth 0. Which node is present at depth 0?
1
1. Okay, now let me explore after depth 0. What is the next higher depth available to me?
1
1, right? Depth 1.
depth 1.
Now I have to explore all the nodes present at depth 1. All the nodes I should explore at once I come to depth 1. Getting the point? Initially I was at depth 0. There what is, only one node is there, my starting node 1. Fine, explored it. That was at depth 0, explored that. Next, the next higher depth available to me is 1. What nodes are present at level 1? Sorry, at depth
2 and
1.
3
Right? So let me explore them. So at depth 1, 2 and 3 are present, right?
Yes.
So what I should do, after exploring 1, I should explore 2 and 3. This is at depth 0. These two are depth 1. What is the next higher depth available to me after 2 and 3? After 2 and 3, depth, next higher depth is 2. Which node is present at depth 2? 4. Fine. So at depth 2, only one node is there, that is 4. So this is how my BFS traversal will be looking like. Okay, you can also say that 1 3 2 4. This is also a BFS traversal. Okay, whatever is present at the lowest depth, whatever is present at the lowest depth, that is 0, should be explored first. Then all the nodes at next higher level, all the nodes of next higher level explored, all the nodes of next higher level. explored. So this is how depth by depth all the nodes I have to explore and search. This is what BFS tells me. So what we are doing effectively, this is level 1, this is level 2, this is level 3. First I will explore level 1, nodes of level 1. Then I will explore nodes of level 2. Then I will explore nodes of level 3. Level by level, I have to do my traversal. This is what BFS tells me. So you can say that this BFS is based on something called level order traversal. That okay, whatever is present, increase your levels one by one. Whatever nodes are present at each level, print them together. That's what I have to do. Okay. Let's take an example more. Let's take an example more. Let's say this one is my starting point. How should the BFS look like as per you? This is level 1. This is level 2. This is level 3. And this is level 4. Tell me, how should the BFS look like?
1, 2, 3, 4, 5, 6.
Is it? How many of you agree with Junaid? Okay. What will be the BFS? What will be the BFS order? First, print all the level 1 nodes. First, print all the level 1 nodes. 1 printed. Now print all the level 2 nodes. 2, 3 printed. Now print
4,
all
5.
the level 3 nodes. 4, 5 printed. Now print all the level 4 nodes. 6 printed. Getting the point? Level by level, all the nodes will be explored. Okay.
Yes.
Any doubt? What is BFS?
No, sir.
Any doubt?
No, sir.
Any doubt to anyone?
No, sir.
No, sir.
Sure. Let's code it.
सर जैसे अभी 1, 2, 3, 4, 5, 6 है ना इसका आंसर.
हाँ.
तो 1, 3, 2, 5, 4, 6 भी हो सकते हैं ये, मतलब राइट साइड से भी.
कौन सा?
राइट साइड से भी स्टार्ट कर सकते हैं सर. 1, 3, 2, 5, 4, 6.
1, 3, 2, 5, 4, 6 डिपेंड है कि तुम्हारा थोड़ा मैट्रिक्स कैसा है, एडजेसेंसी लिस्ट जो कैसा बनाया है वो कैसा है, वो भी हो सकता है, ऐसी कोई बात नहीं है. ठीक है, बिल्कुल हो सकता है. ठीक है. 1, 3, 2, 5, 4, 6. This is also a possibility. This is also a possible BFS sequence. Okay. For a single graph, there can be multiple DFS sequences as well as multiple BFS sequences. Anything is possible. Okay. Okay, can you code it? Can you try to code it? Think of 5 minutes. If I want to code this, what will I do? 5 minutes. उससे ज़्यादा नहीं. Think of 5 minutes. If I want to code it, what will I do? Okay, I will unmute myself at 9:30. Yeah, any idea? How will I code? How should we code this? Any idea? Any idea? Why you people are silent, man? Okay, so let's start one thing. Anything we can do using queues? What do you think? Anything we can use using queues? What do you think? Some queue type of structure if we maintain. What was our graph that we have taken?
Yes sir, क्यू से हो सकता है.
कैसे होगा बोलो? If this is okay, this is my starting point, right? This is my starting point.
Sir, 1 2 3 4 5 6 को साथ में क्यू में ऐड करेंगे.
ऐसे नहीं, बताता हूँ कैसे करता हूँ. देखो, see, let initially my queue is empty. This is my starting point. Enter that into the queue. Fine. Okay, done. Now let's start my traversal. Already have entered the starting node inside the queue. Fine. Now see, I have already a front of the queue. Is it? What is the front of the current front of my queue? What I have? 1. Okay, so let's pop the front. Popped it. Fine. Popped it. What node it is? 1. Print that. Printed. Which node are child nodes of 1?
2 and 3.
2 and 3 are the child nodes of 1. Fine. So okay. Now let's enter 2 and 3 inside the queue. This part is done. 2 and 3 I have entered inside the queue. Okay. So once part is done, 1 has been printed. All the child nodes of 1 has been entered inside the queue. So okay, node 1's work is done. Fine. Now tell me what is the current front of my queue?
2.
2. Okay, take that out. Taken. Node is 2. Let's print it. Printed. Fine. Which node? Any child node of 2 that has not been put inside the queue? Any child node of 2 that has not been put inside the queue? 4, right? So let's put it. Fine. This part is done. Anything else I have to do with 2? It has been printed. All its child nodes, possible child nodes, have been pushed inside the queue. Okay. Fine. Now tell me which is the current front. Which is the current front of my queue? 3. Take that out. Okay, fine. Now next, what should I do? What I should do?
Print 3.
Print 3. Okay, printed. Now any child node of 3 that has not gone inside the queue?
5.
Okay, fine, right? This part is done. 5 inserted into the queue. Anything left to do with the 3? It has been printed also. All its child node have gone inside the queue. Okay, now this part is done. Now what is the current?
4.
What is the current front? 4. Take that out. 4. Any child node of 4 that has
6.
not been
6.
pushed inside? 6. Okay. Print 4, right? First print 4, then put the child nodes inside the queue. Okay. 4's part is done. Now current front is what?
5.
Okay,
5.
5. Take that out. Taken out. Printed. Printed. Any child node of 5, any node that is child of 5 that has
None.
not been pushed inside the queue.
No.
No, sir.
Okay, so do what?
Print.
Its work is done. No node is left, right? Why should I bother? Only, okay, what is the current front?
6.
6. Take that out. Okay, 6 is there. Print it. Print it. Now next, any child node I have of 6 that has not been pushed inside or that has not been printed.
No.
Okay, so its part is also done. Anything is left inside the queue to be taken
No.
out? Any front
No,
is
sir.
there? No. Okay, fine.
सर
So
वो
Queue is empty.
कंफ्यूजन नहीं होगा कि 4 और 5 सेम चाइल्ड कंटेन करते तो
वही तो, उसको
6
कैसे हैंडल करेंगे? कुछ विजिटेड रख सकते हैं?
यस सर
2 से
ये तो
ऑलरेडी
सही है।
अगर विजिट कर दिया 4 को तो 3 से नहीं करूंगा, कुछ कर सकता हूँ ना ऐसा? सेम
हाँ,
डिक्शनरी यूज
globally
करेंगे.
visited डाल के.
Okay, now tell me how should I code this? How should I code this? How should I code this? So okay, let's take Q as a list. Okay, let's implement Q as a list. Fine. What should I do? Tell me now. So okay, this is the starting node. I will call BFS with the starting node. Okay, with what node I should start my BFS traversal? So 1 is my starting node. What shall I do? I should push inside the queue my starting node, right? Pushed. Okay. This part is done. What shall I do next? What should I tell the BFS that okay, this node has already gone inside the queue. Mark that. Mark inside. Okay, let me do one thing first. Let me first declare inside the function 2 global variables, that is visited and edges, right? Okay, marked it that okay, now visited and edges I will be using global. Whatever globally variables we have declared for visited and edges, we will be using that. Okay, now I have pushed inside the queue node. Fine. Who stop? Okay, pushed inside. Now, since it has gone inside the queue, I can say that okay, visited of node is true. Okay, it has been visited already. Now what shall I write? Till what point I should be running? I should be constantly taking the front element of the queue out and printing that. Till what point shall I do? Till the time queue is not empty, right? Till the time queue is not empty, right? While, so what shall I say? Any empty function list supports? What do you think? Any way so that I can check whether my list is empty or not?
Equals to list.
What do you think?
Brackets is not equal to colon double colon.
क्या हुआ? Any function do you know such that yeah, well I can check whether this particular queue is empty?
Sir, length
While-
0 check कर सकते हैं ना?
While len of q is equal to 0.
ये काम करेगा क्या लगता है?
नहीं तो सर while q ले लेते हैं और एक वेरिएबल डिक्लेयर कर देंगे उसमें पॉप करते जाएंगे. While q ले लेते हैं.
Okay, so already let's do one thing. Let's not utilize the length function, not feasible. Okay, let's take that. Okay, right now I have pushed the node, pushed my starting node inside the queue already, right? And I've marked that okay, since the node is going inside my visited dictionary, so it is true. Only one node currently I have into the queue, right? So I can say that the current length of my queue is 1. Fine. So I can now do one thing. I can run a while loop. I can say that okay, while this length is greater than 0. while this length is greater than 0. Now what shall I do? Take the front element out. Front of the queue is what? How shall I access that?
Q dot pop 0.
How q dot pop 0 will it work? Pop element always extracts the last element, right? Not the first.
सर
Yes, sir,
Q
Q
और
ना.
index 0 दे देंगे.
So front will be equal to what? Q of 0, right? Whatever is
Q
the
of 0.
first element. Now do one thing. Okay. Now delete it. Is it? Delete Q of 0. No need of that, right? I have already stored the content of Q of 0 inside front. No need of this. Delete. Now, okay. Check the edges. Let's do one thing. Let's print the front before deleting. Okay. After the deletion also, let's print the content of the front. Print it. Next, I have to all the unvisited child of my present front should be pushed into the queue. So what shall I do for that? How will I do? All the unvisited child nodes of 1 should be pushed inside the queue. So how shall I do that? For I in edges of front, will it work? For all the elements that are present inside edges of front, do what? Check. If I not in visited dictionary, if it has not been visited yet, do what? Q dot inside the queue, push element I, pushed. Next, pushed it. Next, since one element has been added inside the queue, what shall I do? I should increase the length of the queue by 1. Is it correct? And similarly, one thing, since where is it? I am deleting the front element. I am removing the front element of the queue. So here, after the deletion, I should say that L should be decreased by 1. Length of the queue will decrease by 1. Fine. Okay. So I guess our BFS is done here. We have successfully implemented BFS, and let's try it with the graph that we have already made. So what was our graph that we have made already? Previous graph. This particular graph. What was it? 1, 5, 4, 3, right? And 2, 6 was left. Let's see. Let's call it. So what shall I do? For printing all the components using BFS, what shall I do? I should check, right? For I in range that starts from 1, ends at 7. If I not in visited, do what? Call BFS of that node I. Okay. Call BFS using that node I. Let's try this. Okay. What is it? Okay, so that there has been some issues. See what is happening. 4, 3, 4, 3, 4, 3. Constantly something is getting printed. Have we missed something inside our code? Oh. Have we missed something? What we have missed here? What we have missed here? So once we were adding things, have I marked that, okay, since it is going inside the queue, I should mark that, okay, this thing should be true, right? This has already been visited. This is going inside the queue. This is getting visited. So do what? Push this entire thing inside the dictionary, right? This is what we were missing that time. Yeah, now let's run. Is the answer coming correct? Tell me that. If 1 is the starting point, is the answer coming correct? The BFS, level order traversal, is it coming correct or not? 1 is the starting point. Let's say 1 is the starting point. So how should the traversal using BFS look like? First 1 will be printed. What is the next level? Next level node of 1, only 1, 5. Now from 5, 4, 3, both are there. Both lie at the next level. Then 4, 3 should be printed. Since 2 is the next component, if I start from 2, 2, 6 will be printed. So my final answer is this. Am I getting the same thing? 1, 5, 4, 3, 2, 6. Tell me that.
Yes, sir.
Tell me, shall I go for a dry run or have you understood the part? How we have done that?
सर एक बार क्विक रिकैप दीजिए ना पूरे कोड का.
चलो ठीक है, करते हैं. ड्राई रन ही करते हैं, ठीक है.
सर स्टार्ट से.
ड्राई रन ही करते हैं पूरा ही, ठीक है. Okay, see, I starts from where? I starts from 1, it goes up to till 6, right? For I equal to 7, this loop terminates, right? For I equal to 7, the loop terminates, right? Initially, the visited dictionary is empty. The visited dictionary is empty. Visited dictionary is empty. So tell me, I not in dictionary, is it true? I not in dictionary. What is the value of I? Starts with 1. I starts with 1 for I equal to 1. Is it true? Visited. I not in visited. Is this true? Value of I. I is 1. 1 is not in dictionary. True or false?
True, sir.
True, sir.
So call the BFS function. Call the BFS with 1. Call the BFS function with node 1. Fine. From node 1, I will start my BFS traversal. Let's go above and see what my BFS is doing. Fine. What my BFS is doing. Okay. So, okay, I've made a queue here, made a queue. That is an empty thing, right? Initially, the queue is empty. So what I have done, queue.append node. What is the value of current node I have? What is the value of node that I have passed?
1.
1, right? 1 is the value of node that I have passed. So, okay, queue.append node. Inside the queue, push 1. Pushed. Visited node equal to true. Is it? Visited
Yes,
node
sir.
equal to true. Make a key 1, mark that, okay, now this has been, since it has gone inside the queue, this has been visited, right? This has been visited, and make a variable L that is equal to 1. Length of my queue is 1, fine. Okay, while L greater than 0. So tell me, is this condition true? L is greater than 0?
Yes, sir.
Yes, sir.
Okay, fine. So what is it? What should I do? Front equal to Q of 0. Let's make a front. Let's make a front. Front equal to Q of 0. What is Q of 0 right now?
Sir, 1.
1, right? Okay, fine. Grabbed it. Delete Q of 0. Remove this. Removed it. No element is inside my queue right now. Fine. L minus equal to 1. Okay, reduce the value of L to 0. L minus. So, okay, reduce that. Okay, no element is inside my queue right now. Its value will be, its length will be 0. Done. Print front. What is the value of front? I have 1. So print it. Print it. Now, for I in edges of front, what will be kept inside the list of 1? What will be kept inside the list of 1 as per my graph? What is my graph rather? What was my graph that we were using? 1, 5,
4, 3.
4, 3 and 2, 6, right? This was my graph. Now tell me, what will be kept inside the list of 1? What will be kept? What will be there inside the list of 1? We are keeping an adjacency list, right? What will be kept? What will be there inside the list of 1? What do adjacency list stores?
Sir, 1.
1 के लिस्ट में क्या होगा? एडजेसेंसी लिस्ट है ना, एजेस है। 1 के लिस्ट में क्या रहेगा बताओ?
Sir, 5.
5, right? 5 is the only element that has an edge with 1, right? So 5 will be present inside the list of 1. Okay. So, okay. What is it? For I in edges of front, I will be pointing here. I will map to all the elements present inside the list of 1, 1 by 1. Fine. I not in visited. What is the current value of I? I am having 5. Okay, so let's change it a little bit. I guess you might confuse. Let's name it J rather, right? Okay. So now we should say that, okay, J will take all the values. J will map to all the values 1 by 1 that is kept inside the list of 1. So J is pointing to 5 first. Fine. So, okay, J not in visited. Initially J is 5. Firstly J is 5. Only one element. So J is first taking the value 5. J not in visited. Is it true?
Yes,
Inside
sir.
the visited dictionary, we don't have any key called 5. Okay, this is true. So what is happening? What will happen? Tell me.
Sir, 5 लिख देंगे सर, append हो जाएगा, so visit करेंगे सर, true हो जाएगा.
Q dot append J, whatever is the value J is having, append that inside the Q. Appended.
Yes.
Visited of J, make a key inside the visited dictionary and mark that true. Done.
True.
L plus equal to 1. L plus equal to 1. L is increased by 1. Fine. Go back to the loop. Any more element present inside the list?
No.
No, sir.
Okay, fine. So this part is done. For the value of 1, for the value front equal to 1, this everything is done. Fine. Remove this and go back to the while loop. Now. Tell me, what is the current value of L we are having? 1. So is it greater than 0?
True.
True. Okay, now what is the current front we will have?
Sir, 0.
Current front will be what? What will be the value of front?
Sir, 1. Sorry, sir. 1.
Is it? What is Q of 0?
5.
What is kept at Q of 0? 5, right? 5 will be front. 5 will be the current front of my Q. Fine. Delete this. Delete it.
Yes.
Okay. L minus equal to 1. Okay. Nothing inside the Q right now. Change its value to be 0. Done. Now print the front. Where is it? Where I was printing? Okay, let's print it here. Initially 1 was printed. Now 5. 5 is the front. This will be printed. Fine. Now start again. Tell me what will be kept at the adjacency list of 5. What will be kept at the adjacency list of 5?
1, 4, 3.
Okay, exactly. At the adjacency list of 5, what will be kept?
1, 4, 3.
1, 4, 3. Okay. J. Okay, fine. So J will point to all the elements 1 by 1. J will point to all the elements 1 by 1. J will take the value of 1 first. Fine. Now tell me, if J not in visited, is it true?
False, sir. Visited.
False. 1 is already inside the visited, right? So skip the lines, go back to the loop. Now J increments by 1. J comes here. Now tell me, what about 4?
Sir,
visited.
Not in visited, true?
Yes,
True.
sir.
So do what?
Append होगा.
Q dot append 4.
Yes.
Append
में
4
append
inside
होगा.
the Q. Next.
फिर उसको visited mark
Visit करेंगे, sir.
Visited 4 will be marked. 4 will be marked. Okay, that 4 has been visited. This is true. Fine. Next.
Increase
L
1.
increment by 1.
Next. Value of
L
L will be
increment
increased by 1. What?
Yes,
Let me
sir.
keep L here. L was 0. It will be marked 1. Fine. Done. Next, what will happen?
Go back to for loop.
Go back to the for loop, right? Go back to the for loop. Now again from here I will be going back to the for loop. Anything else? Now J points here. J points at 3. What will happen now? 3 is not visited. 3 is not
True.
visited. So append 3 inside the queue. Now visited J equal to true.
3 equals to 3 is
3 will
to
be
2.
marked true. Now next L plus
Visited
will be equal
okay.
to 1. Increase the value of L by 1, 2. So exactly 2 elements I have inside the queue. So increase that. Fine. Anything else left inside?
No.
The queue of 5, sorry, the list of 5, nothing. Okay, so let's go back to the loop, while loop.
While
Fine. What is the current length of my queue? 2, right?
2.
Is it greater than 0?
True.
Is it greater than 0? True. Fine. So what will happen? Front equal to
Front.
queue of 0. What is queue of 0 right now?
4.
Phone. So front will be equal to 4 now. Delete this part. Delete it. L minus equal to only one element inside the queue right now. So okay, decrease the value of L by 1. Decreased. Print front. Print front. What is the value of front? Okay, 4 printed. Next, what will happen?
While loop जाएगा फिर.
For J in edges of front. What is my front right now?
4.
4. So what should be present inside the list of 4? Tell me that. What should be present inside list of 4? Edges of front means what is the content of the list that 4 is having? What should be the content as per the given graph?
5.
Only 5, right? Only one edge. From 4 to 5, we have only one edge. 4 is having edge with only one element, that is 5. Fine.
5.
So J starts iterating over this. J starts iterating over the list. J not in visited. True or false? J is
False.
first equal to 5. False. Line is skipped. It will go back. It will go back to the for loop. Anything left for J to point? Nothing is right. So okay, the chapter of 4 is over. Chapter of 4 is over. It will go back. Now let us go back to the while loop. What is the current value of L we are having?
1.
Is it greater than 0?
True.
True. Okay, fine. L is value of L right now I'm having is 1. It is greater than 0. Again, what is the queue of 0? Front element of the queue?
3.
3. Then delete queue of 0. Delete this. L minus equal to 1.
0.
0. Fine. Print front. What is front right now?
3.
3. Print it. Print it. Next. For J in edges of front, what is kept at the list of front?
3.
3 is the front. What is the list of it?
5.
What will be kept? 5 only. Only one edge is there between 3 and 5. Only one edge. So 3 has only one edge with 5. Fine. This part is done. Okay. Now next, what should I do? J starts iterating over it. J starts iterating over it. Okay. J's initial first value of J is 5. J not in visited. True or false?
False.
False, sir.
False. So this entire thing will be skipped. Anywhere else, J can go. J can take no values, right? It will go back to the loop now. While loop.
Yes, sir.
L value of L is 0. Is it greater than 0? True or false?
False.
So now this entire loop terminates. I think our first BFS function is done. BFS for component 1 is done, right? Is
Yes,
it?
sir.
Okay.
Yes, sir.
Fine. BFS for our component is done. Okay, so let's come back from wherever our DFS was called. Let's come back from wherever our DFS was called. Okay, so I equal to 1. At I equal to 1, I have called for BFS of 1 because it was not inside my visited. Now I goes to 2. Value of I goes to 2. So now tell me, is 2 inside visited? Is it true? 2 inside visited? 2 is inside the visited dictionary. True or false?
False.
False.
Okay, so we will call BFS of 2 now. We'll call BFS of 2. Called. Fine. Now next, what should I do?
While loop.
Okay, BFS of 2, right? We are again into the BFS function. Okay, so again declare an empty queue. Declare an empty queue. Declare an empty queue. Declared. Queue dot append node. What is the current node I have? 2.
2.
Okay,
2.
done. Declare variable L to be 1. And okay, inside the visited, insert 2. Insert 2 with value true. Okay, that true has also been visited. Now, again, come to the loop. What is the current value of L I am having? 1.
1.
Greater than 0?
Yes, sir.
True.
True.
So what is the front?
Front is 2.
Front is 2, right? Only one element. Delete. Deleted. Next. L minus 1.
-1.
Reduce by
Zero.
1. Okay. Next, print
Front.
front. Print it. Now go inside. What will be kept inside the list of 2? What is the value that will be kept
6.
inside the list of 2? Only one element, right? 6.
6.
Okay, fine. Now J will start iterating from here. J is at 6. J not in visited. 6 not in visited. True or false?
True.
True.
Okay, so what to do? J, Q dot append J.
Q
Inside
is
Q,
equals to 6.
inside 6 and visited. What will happen? Visited of 6, true.
6 is to 2.
Now insert 6 as the key, mark it to be true. Value of L, increase it by 1. Done?
Yes, sir.
Go back to the while loop. Okay, L greater than 0, true.
True.
Yes, sir. True.
Okay, front equal to value of front now. What it will be? 6.
6.
Delete Q. Delete this. Next.
L minus
Okay, value of L becomes 0. Next.
Print
Print
6.
front.
front.
Print 6. Done. Next.
Go to
For
the
J
left.
in
For
edge.
loop.
For J in edges of front, what will happen?
Sir,
What will be kept?
sir, 2.
6.
6 inside the list of 6. Only 2 will be kept.
2.
Only one. 6 is having edge with 2 only. Nothing else, right? If J not in visited, what will happen?
False.
Sir,
Not, right? J starts from here and this is false. 2 is already visited. So this entire thing will be skipped. Go back to
While
while
loop.
loop. Okay. Is this 0? Value of
False.
Yes, sir.
L is 0. So yeah, this entire loop terminates. And
Terminate.
I think we are done with BFS. So we have printed second component also. True.
Yes,
True.
sir.
Okay, come back. Come back to the lower for loop. Come back to the lower for loop. Okay, now tell me, all nodes have been visited. I was standing at 2. Now what about 3, 4, 5, 6? What will happen? Will any BFS call be made?
No.
I will be start with 2. 3 not in visited. True. 3 is already here. False. 4.
False.
Now I goes to 4. 4 is also inside the dictionary. So this is again false. 5 is also inside the dictionary. This condition is again false. 6 is again inside the dictionary. This condition is again false. So no more calls will be made. And finally our answer is this 154326. Okay. Tell me, is it clear how we have utilized BFS?
Yes.
Tell me
सर
that.
मुझे प्रोग्राम में एरर आ रहा है.
क्या आ रहा है? अच्छा मैं देखूंगा. रख लो. मैं देखूंगा इसमें. At end of the class में. Tell me, BFS is clear or not?
Yes, clear.
All of you?
Clear, sir.
Yes, sir.
Easy था ना BFS? DFS से ज्यादा?
हाँ, कल का जो डाउट था क्लियर.
So see one thing. DFS is recursive stack based, and you have to implement BFS using queue. If somebody asks you to do level order traversal of tree, of any binary tree also, utilize this queue. Whatever we have done using queue, start with the root, keep on, and do the same BFS types operation. Insert this queue into the queue, insert the root inside the queue, root element, then extract that out, extract the front of the queue, and then mark that into the visited category and push all its child nodes inside the queue. Similar way, you can get the level order traversal of any binary tree also. No problem, no difference. Okay, कर लोगे बताओ. There is nothing, no difference between a BFS and a level order traversal. This is what I want to say. Just level order traversal कोई बोले उसकी जगह BFS कर देना, हो जाएगा काम. ठीक है, level by level traversal मांगता है, बोलो. Okay, is this part clear to all of you? Hello.
Yes, sir.
Yes, sir.
Okay, so let's go for one thing, something we called as shortest path. Go here. So let's take graph like this. Okay, what do you mean by a path? Path inside a graph or a tree.
नोड सर क्या है तो
If
edges
this
sir.
is, if let's say
Edges.
I am at the starting point. Any idea what do you mean by path in a tree?
Shortest path means way of traverse.
सर edges मतलब 1 से 2 जाना है
Edges.
तो edge जो है.
और कुछ बताओ. Any idea what can we say about path? One and there is a path between 1 and 4. What will we say about that?
One.
Way to reach the node is known as path.
Okay, between two nodes, path means finite sequence of
Nodes.
nodes and edges. Not infinite, but finite. Okay, so between 1 and 4, if I say between node 1 and node 4, I want to say path exists. What paths can you propose? What path can you propose? 1, 2, 4 is a path. 1, 2, 4 is a path. Finite edges and nodes in between 1 and 4. 2 edges and 1 node in between. 2 edges and 1 node in between 1 and 4. Finite sequence, right? Is it?
Yes.
Anything infinite you are able to see between 1 and 4?
No.
Okay, now tell me one thing. Is this also a path? 1, 3, 5, 2, 4. Is it also a path? 1, I come to 3. From 3, I come to 5. From 5, I come to 2. And from 2, I come to 4. Is it also a path?
Yes,
Yes.
sir.
Okay, how many paths else you can define using this?
So 1 2 3 3 to 5 5 to 6 6 to 4.
Yeah, 1 to 3, 3 to 5, 5 to 6,
5
6
to
to
6
4.
and 6 to 4.
Right? This is also a path between 1 and 4. So what do you mean by path? Finite sequence of nodes and edges between two nodes. A path between any two nodes V1 and V2 is a finite sequence of nodes and edges. That's all.
Yes.
समझ आ गया? पहले बताओ. All of you. Okay, if I ask you, what is the path between, list paths between 2 and 6, let's say. What path you can propose?
2 5 6.
Okay, 2, 5, 6. First 2, 5, 6. Acha, 2, 4, 6. Else? 2, 5, 6, 2, 4, 6. What else?
2 1 3 5 6.
2, 1, 3,
3
5,
5
6.
6.
Okay. हो गया?
Yes, sir.
What about this? Is this a path? 2, 1, 3,
3 2
5, 2,
4 6.
4, 6. Will it also be a path?
Yes.
Yes, sir.
Nothing. Already infinite no infinite sequence, right? This is also a finite sequence only. So one thing remember, for two paths to be exist, two paths to be not, sorry, these two paths are said to be different. They are different if the sequence between 2 and 6, what we are writing is different. Between 2 and 6, we have a different sequence here. This is different from this. Why? Because in between 2 and 6, okay, at least one node is different, right?
Yes.
This 2, 4, 6 is different from this path. Why? This 2, 4, 6 is different. Again, here also 2, 4, 6 is coming, but this is different from this. Why?
Starting from 2 to 1 3 5.
Starting from 2, entire of this sequence of nodes and edges are different, right?
Yes,
Yes.
sir.
Here only 4 is there. Here, how many nodes? 1, 2, 3, 4, 5. 5 nodes is there.
Yes,
So
sir.
this path and this path are different. Fine. Okay, tell me, what do you mean by length of this path? What can you infer? That, okay, what is the length of this path? Whatever path I am following.
The depth of the
Is it, suppose that I am saying that, okay, 1 to 4, I want to go. 1 to 4 I want to go, so I am following this path. 1 3
1, 2,
5
4.
1 3 5 6 4. This path I am following. So how many edges I need to travel? How many
4
edges I
edges.
need to travel? Right? 1 2 3 4. These 4 edges I need to travel. Fine. So what this is called? What is the length of this path? What is the cost
4.
or length? You can also say cost. We can also say length. Cost or length of this path is 4. That is equal to number of edges I am traveling to reach 4, right? So what I can say about shortest path? What is shortest path then?
1 to 4.
Now what is the shortest path?
Minimum number of edges.
Minimum number of edges I should travel to reach from 1 to 4, right? Is it?
Yes.
Minimum number of edges I should travel to reach from 1 to 4. This is the meaning of shortest path. Getting the point? Tell me that.
Yeah.
So which path will lead to the shortest
1
distance
to
between 1 and 4? 1, 2 and 4. This path, right? So okay, I have to devise an algorithm. That you will be given a starting point. You have to reach a destination. You have to tell what is the minimum cost with which I can reach this destination from the starting point. Ideally, you have to tell minimum cost. That means you have to say what is the shortest path between the start and the destination. So what can you say here? If suppose this 2 is my starting point, I want to reach 6 from 2. What is the shortest path between 2 and 6?
254.
2 4 6.
246 and 256. 2 paths are there. For if I utilize anyone, I will be costing 2 only, 2 edges. From here and here, using 2, I can also reach 6 using 2 edges. From if I utilize 5 also, I can reach 6 using 2 edges. Tell me what shall I do? What should I do? Any idea you can make that, okay, if I start from 2, what algorithm I should use such that I will be able to reach 6 from 2? What shall I do?
सर एक बार रिपीट कीजिए ना.
क्या करें? कौन सा बताओ?
जो आपका क्वेश्चन अभी का जो क्वेश्चन लास्ट.
Find the short from 2 to 6 is my starting end. What should I do to calculate what is the minimum number of edges I require to reach from 2 to 6? What shall I tell me that?
2 edges sir.
नहीं तो क्या करें? कैसे फाइंड आउट करोगे? ग्राफ तो कुछ भी हो सकता है ना, कैसे फाइंड आउट करोगे? क्या है गुरु मंत्र, क्या है उसके लिए?
सर उन दोनों के बीच में एक नोड है सर.
Anything you can do using labels? Can you tell anything using labels? If 2 is the starting point, is it by default at level 1, right? Or depth 0? It is by default at depth 0. This is my starting point. So can I say shortest path between 2 and 6 is the depth of 6 when my starting point is 2? Is it? Can I say something like this? Shortest path between 2 and 6. Shortest path between 2 and 6 is the depth of 6. Is the depth of 6 when starting point is 2. Can I say this? Tell me that. हो रहा है? बताओ तो.
नहीं समझा सर.
Shortest path between 2 and 6. Length of the shortest path, sorry. Length or cost of shortest path from going, if I start at 2 and I want to reach 6, is the depth of 6 when my starting point of the graph is 2. करेगा? काम चलेगा? बोलो तो. Can I say this? If
Well,
2 is if 2 is my starting point, what is the depth of 6? Who will tell?
2.
So is
0.
that the shortest path? Is it the
Yes.
length of shortest path?
Yes.
Okay, so if I start at 2, which nodes lie at depth 1 then?
Lie at depth 1.
Depth 1.
Depth 1 पे स्टार्टिंग पॉइंट कौन सा रखेगा?
2 होगा. अगर स्टार्टिंग पॉइंट 2 है तो डेप्थ 1 पे क्या क्या आएगा?
1 पे 5 4
और 1 नहीं आएगा?
1 भी आएगा.
1 will be coming at depth 1, 5 will be coming at depth 1, 4 will be coming at depth 1. If 2 is my starting point. Rest 3 will be coming at depth 2, 6 will be coming at depth 2. So one thing keep in mind, when the graph is undirected, okay, if you are given a starting point, you want and given a destination, from start to the destination I have to go. What is the shortest path? What is the length of the shortest path? Is equal to the depth of
the node.
Depth of the destination node. Okay, start is fixed, right? Start element is fixed. I have to just find out what is the depth of the destination and I'm done. But how will I find? Who will tell? Let me go to some other page with the same graph. One, 3, 2. What is next?
5 4.
5. Next 4 6, right? Okay. How will I find the depth? How will I find the depth of every element? If 2 is my starting point, how will I find the depth? Any idea? 2 is the starting point, its depth is 0. Then which elements are at depth 1? This 1 will be at depth 1, 5 will be at depth 1, and 5 will be at depth 1. All of them can be reached from 2 just by traveling one node. So their depths are 1. Next, tell me. Can I utilize BFS? BFS can I utilize?
BFS से सिर्फ visited निकल जाएगा और वो queue में append कर सकते हैं, इतना कर सकते हैं.
Okay, tell me one thing. I will keep a separate array. What is the depth of each node? Separate array of 6. Array of length 6. Initially, everything will be 0. Anything will be 0, 1, 2, 3, 4, 5, 6, right? Let's push now. Since my starting point is fixed, push into the queue 2. Okay, right?
Yeah.
Its depth is by default 0. Depth of 2 is 0. Fine, no problem. Now take this out. Take this 2 out as the front. Take this 2 out as the front. What should I do now?
No, उसके
all the child nodes of 2 are at depth 1, right? All the child nodes of 2 are at depth 1. So okay.
उसको एक separate इसमें
So
list
okay, 1, 5, and 3. Mark there, increase whatever is the depth. What is the depth of 2, 0? So I can say 1, 5, 6. These are the child nodes. So okay.
Mark 1.
Mark their depth as 0 plus 1. 1 more than the previous node. 1 more than the previous node. Fine. 0. What is 5? And 6. Marked. Next. Next, what shall I do? What is the and push them? Push all of them into the queue. 1, 5, 6. Pushed. Now, what is the current? What is the next?
Front.
Sorry, I think it was 4, right? It was not 6, it was 4. It was 4. And this will be 0 only. This will be 0 only. Now, 1 is the current. 1 is what?
Front.
My current front, take that out. Take that out. 1 is having only one node to be explored, right? Only one node to be explored. 3. Okay, so mark that. Okay, I have visited 1. 1 was at depth 1. Current depth of 1 is 1. So what will be the expected depth of 3? 1 more than the previous node. 1 more than the previous. Okay. So yeah, mark its value to be 1 plus 1. That is 2. Mark. Anything left for 1 to do?
No.
Okay. So yeah, what is the next front of my queue? 5.
5.
Okay. So 3 has been right. Now insert 3 also. Where is it? Insert 3 also into the queue. Insert it. Now next front is 5. Take that out. And what is the node that is left for 5 to be explored? Which node this 5 can explore?
6B और 3B है.
नहीं, 3 तो आ चुका है ना. Inside the
6
queue.
भी तो आया है ना सर.
6 नहीं आया है. Sorry यार, ये तो 4 है. 4 है.
Sorry.
This was 4. Sorry, from my end, this is a mistake. This will be 4. Fine. So any 6 has not been explored yet. 5 can explore 6. What is the current?
Insert.
What is the current depth of 5? 1.
1.
So update the depth of 6 to be 1 plus 1. That is
1 plus 1, 2.
Fine. Anything 5 can do else?
No.
No. Okay. 5 का किस्सा खत्म. 4. Let's take the case of 4 now. Anything 4 can do else?
No.
No. 4 का किस्सा खत्म. Anything 3 can do else?
No.
No. 3 का किस्सा खत्म. What is the final depth of 6?
2.
2. Right. So this is the minimum. This is the minimum length of the path through which I can reach from 2 to 6. Can you do it? Tell me. How many of you can implement this?
Same BFS ही use करना पड़ेगा.
एकदम BFS कुछ नहीं, बस एक एक्स्ट्रा एरे अलग से आएगा, डेप्थ एरे.
लास्ट में हाँ डेप्थ एरे ऐड करना पड़ेगा.
Tell me how many of you can implement this? कोड कर लोगे तो बताओ. जस्ट सिंपल BFS है, बस एक डेप्थ एरे बनाना है और तो कुछ नहीं करना. इज इट?
Yes.
What about the rest? What shall I assume? Tell me. Can you do it? Hello. Okay, this is your task. I have told you what to do to make the depth array. Try to implement that on Sunday. Try to implement that on Sunday, and if you are still finding difficulty, we will discuss that on Monday or any other day. Okay, Monday, Tuesday, any day, because core CSE part will be starting. Now tell me one thing. Till now, what we have seen, some graphs like this, What was my graph? Was it 4? What was my graph? Let me see once. Okay, 1 3 5 2 6 4. 1 3 2. So are you noticing anything? The edges are plain, right? Anything written on the edges? Anything written on the edges?
No, sir.
So such kind of graphs are called unweighted graphs. Unweighted. Unweighted means if nothing is mentioned inside the edges, by default, you will have the weight or cost to travel from one node to another node as 1. It requires exactly cost 1 to travel from 1 to 3. Okay, if nothing is mentioned, no weight is mentioned, that okay, this edge does not have a weight, by default it's having weight 1. Okay, getting the point or not? Nothing is mentioned, so I can say that okay, if I want to go from 1 to 2, this edge will cost me exactly 1 unit, and hence such kind of graphs are called unweighted graphs. No weights are mentioned here. That means each edge costs 1 unit. Cost of each edge is 1 unit. Now we have some other kinds of graphs also, not only unweighted, but some weighted graphs also we have. What is it? 1, 3, 4. What was it? 5, right? 5 or 4 was it? 5, 4. 5, 4, 6. Now suppose there are some costs. Some costs are also given along with it. That from 1 to 3, I require cost 5 to go. From 1 to 2, I require cost 6 to go. Now rest 2, 4, 9, 18, 3. Now tell me what will be the shortest least cost path from 1 to 6. From 2 to 6, if I want to go, what is the least cost path? Who will tell?
2, 4, 6.
Least cost.
2, 4, 6. Well,
correct. 2, 4, 6, right? What will be the cost?
12.
What will be the cost if I want to go from 2 to 6? I have
12.
multiple paths, right? But 2, 4, 6, this will cost 12, and rest 2, 5, 6,
22.
if I take,
22.
it will cost 22. All other paths, any other path I can take also. What do you think? Any other path if I take, that will cost more than 12, definitely.
2, 1, 3, 5, 6.
2, 1,
3, 5, 6.
5, 6. 2, 1, 3, 5, 6. So what will be the cost of it? From 2 to 1, 6 added. Now
5, 11.
1 to 3. Sorry, 1, 2, 3. Yeah, 5 added. Now next 3 to 5, 2 added. Now next
18.
5 to 6, 18 added. So what is the total cost?
11.
11, 13,
13, 23, 41.
31. 31, right? 13 plus 18, 21. Sorry, 31. 13 plus 18, 31. So what is the least cost I may get? That is 12. Now what idea you have? What idea you can, similarly, let's suppose I want to go from okay, let's take another example. No need to
2
stick
to
here.
3.
सर ये नोट पे जो 5, 6 ये क्या है सर?
Weight of the edge.
Weight of the edge. What is the cost of it? Fine.
मतलब
Let's take
अलग से
some-
वेट निकाले सर.
हाँ, वेट होता है. अब जाओगे 1 से 3 पे तो एक कॉस्ट देना पड़ेगा, 5 रुपए देना पड़ेगा. टोल टैक्स देते हो ना, ऐसा ही.
तो मत कुछ भी कर सकते हैं, कुछ सकते हैं ना सर.
कोई भी पाथ का कॉस्ट निकाल सकते हैं आप. ठीक है, आपका
नहीं सर, मतलब कुछ भी रख सकते हैं उस पाथ का नाम.
हाँ, कुछ भी रख सकते हैं. ठीक है. 7, let's say, let's not say 7, 5. What is it, man? 2, let's say. Any other? We have missed 1, 3, 2, 3, 5, 6, 5. Let's say there is an edge here also. 2, 1, 5, 3, 6, 4, 5. This is it. Now tell me what to do. If I want to go from 1 to 5, if I want to go from 1 to 5, What should be the least cost? What is the least cost?
145.
Why? This is 5, right? This is 5.
Yes, sir. 145.
145. 145. What is the cost of this?
3.
1 and 4. 2.
Hmm.
And 4 and 5 is weighted 6, right?
6,
This weight is
okay.
6.
Yes, sir.
Cost is 8. Any other path we can take? Let's suppose there had been another, there had been another edge from here, and it would have been 4.
So,
what
sir,
if-
135.
then 135 would have given me the shortest path, right? From 1
Yes.
to 3, what is the cost? From 1
One.
through 3. 1 from 3
1,
to 5,
5.
what is the cost?
4.
4, 5 है sir. 5 हुआ.
ना 5
What?
ऊपर है, 3 to 4 का 5 है.
Yes, sir. 5
Three.
हुआ मतलब.
हाँ, total में 5 हुआ. So least cost is this.
Yes,
This
sir.
path. Now my point is, how will I find the cost of shortest path? So least cost path, how will I find? Least cost path, how will I find this?
H की वैल्यू रख दे.
क्या करोगे अब? बोलो. तब तो चलो BFS से निकाल भी लिया, अब क्या करेंगे?
BFS से पहले ये मिल जाएगा, शॉर्टेस्ट पाथ.
Shortest path, वो तो अब नहीं कहो. तब तो by default we know that edge weight will be 1 because the graph is undirected. Now what? Now अब क्या करेंगे? What we will do now? We know that each and every edge is weighted. I have to find the least cost path now. What we will do now? Starting point, let's say, is 1. Here, starting point is 1. What we will do now? Any idea?
Destination sir?
Destination is 5.
सर
हम्म.
सोर्स टू डेस्टिनेशन से कितने वे हो रहे हैं पहुंचने, मतलब जैसे कितने पाथ बन रहे हैं वो करके सबका वेट, मतलब सबके वेट का सम निकाल के, सबके सम जो वेटेड के सम है उनको कंपेयर करके निकाल सकते हैं. आई थिंक
कर सकते हैं, बिल्कुल कर सकते हैं.
पहले BFS से उसका शॉर्टेस्ट पाथ निकाल लेंगे. जो भी
फायदा नहीं
शॉर्टेस्ट
है.
पाथ.
नहीं, जरूरी नहीं है.
नहीं
जैसा
सर,
कि-
मतलब नंबर ऑफ वेज कितने हैं वो पहले निकाल के फिर कंपैरिजन करेंगे सबके सम को.
तब कंपेयर
सब
करेंगे.
सही है, तब सही है. ये करोगे
हाँ.
तो आ जाएगा, पर करोगे कैसे?
क्योंकि शॉर्टेस्ट पाथ तो BFS से मिल जाएगा.
भाई लेकिन अगर शॉर्टेस्ट पाथ मेरा, अगर उसका वेट ज्यादा रहा तो फिर लीस्ट कॉस्ट पाथ नहीं मिलेगा ना.
दैट्स द पॉइंट. लीस्ट
Compare
कॉस्ट
करना
पाथ
रहेगा.
चाहिए मेरे को. शॉर्टेस्ट पाथ तो चलो, शॉर्टेस्ट पाथ वही हुआ जो लीस्ट कॉस्ट दे रहा है, वही शॉर्टेस्ट पाथ हुआ.
वही लीस्ट कॉस्ट देगा ना.
हाँ, नहीं, ऐसा कुछ नहीं है. शॉर्टेस्ट पाथ अगर समझ रहे हो कि एज कितना कवर कर रहा हूं, सो दैट्स डेफिनेशन करेक्ट फॉर अनवेटेड ग्राफ्स.
ओके.
That is correct for unweighted graphs. But once the graph is weighted, what will be the definition of shortest path? The path that is giving me the least cost path. That will be the definition of shortest path.
Okay.
Fine.
So
what will I do here? What can I do here?
पहले पाथ कैलकुलेट करना पड़ेगा.
लीस्ट कॉस्ट पाथ और शॉर्टेस्ट पाथ अलग अलग हुआ ना.
नहीं, ये दोनों चीज वेटेड के लिए सेम चीज है. वेटेड ग्राफ के लिए सेम चीज है.
अनवेटेड के लिए अलग है.
अनवेटेड के लिए तो खैर चलो, ये एज कोई कॉस्ट का मैटर ही नहीं आता. बाय डिफॉल्ट सबका कॉस्ट 1 है. तो शॉर्टेस्ट पाथ क्या हुआ? जो BFS उसका डेप्थ निकाल के काम हो गया.
सर एग्जांपल बताओ, अगर जैसे शॉर्टेस्ट पाथ जैसे 3 और 5 है.
हाँ.
3 से 5 के लिए. मगर वही अगर 3, 1, 4, 5 करके जाए और उसका लीस्ट कॉस्ट पाथ सबसे कम आ रहा है.
चलो देखते हैं कहां पर है. 3 से 5 जाने का कॉस्ट 4 आ रहा है. ठीक है, 3 से 5 जाने का कॉस्ट
10 ले लेते.
ठीक है, चलो 10 है यहाँ पे.
हाँ. और वही 3, 1, 2, 4, 5 करके जाएंगे तो उसका एग्जांपल 6 आ रहा है.
3, 1, 2,
4, 5 करके जाएंगे.
4, 5. ओके, व्हाट इज द कॉस्ट ऑफ इट?
एग्जांपल अगर
1, 2, 6 राइट ना.
फ्रॉम एग्जांपल अगर 6 ले लेते टोटल.
3, 1, 4 है ना. 3, 1, 4 है. 2 तो नहीं आ रहा है बीच में. 3, 1, 4, 5 है. दिस इज द थिंग. Let's suppose 10. 3 to 5 I can go using 10. Cost 10. So yeah, using this 3, 1, 4, 5, what is the cost? 1, 2 and 6, 9. This is the
9.
shortest path. Yeah, this will be regarded as the shortest path. This
Okay.
will be regarded as the
वहां
shortest path.
पे कितने एजेस ट्रैवल कर रहे हैं वो मैटर नहीं करेगा,
कॉस्ट क्या
वेट
है,
मैटर करेगा.
कॉस्ट क्या है, वेट क्या है, डेफिनेटली.
ओके.
तो सर फिर दोनों अलग हुआ ना, मतलब शॉर्टेस्ट पाथ.
You can assume that this weight is the length of the edge. Is the length of the edge. Weight का length कितना है, edge का length कितना है, that is given by 1. Okay, so if I am traveling from 3 to 5 using this edge, I am traveling 10 units. But if I am taking this path 3 1 2 sorry 3 1 4 5, then actually I am traveling 9 units, right? So this is my shortest path. Getting the point? So this is my shortest path. Assume like this.
वेटेड में एज मैटर नहीं करेगा.
ना वेटेड में नंबर ऑफ एजेस ने, एजेस की लेंथ क्या है वो मैटर करेगी. फाइन,
वो मैटर करेगा.
सर सबकी वैल्यू वो वेट 1 हो तो
सबकी वैल्यू
तो फिर वो
तब तो अनडिरेक्टेड हो गया, तब तो अनडिरेक्टेड हो गया. ठीक है, सबकी वैल्यू अगर 1 है, इफ एवरी वेट एवरी एज हैज अ वेट 1, then that is undirected.
ओके सर.
Fine. Now tell me what will I do here? What should I do?
वही है सिंपल. कितने एजेस यानी कितने तरीके हैं वो एज तक नोड तक पहुंचने के, वो कैलकुलेट करेंगे पहले, फिर उनका वेट कैलकुलेट करके कंपेयर करना पड़ेगा.
यस सर.
Okay, one thing. So how will you implement that? How will you implement that? What was my graph? Previous graph?
1
1. Next.
2 sorry
1
4
4 3. Next.
5
5
6 4
3 2. Next.
6
5. This was the weight was 5, right? Now next 6 was here, right? What is the weight of 1 and 4? 2.
2
What is the weight of
1
this was 1, right? And next
3 to 2 का 4 आएगा.
3.
3 से 2 का 4.
6. Next 3 से 5 का 10 and 3 से 2 का
2 4.
Okay, fine. Now tell me, let's keep a distance. Let's keep a let's keep a distance here, and all of them let us mark that. Okay, यहाँ पे कोई भी लेंथ तो 100 से ज्यादा जा नहीं सकती. Let's keep a maximum value 100 for everyone. That okay, from the start, this 3 is my start, and let us initialize every value in my array, distance array. That okay, to be 100. That okay, from the start I can visit every node from 100. Since 3 is the start, I can say that okay, this third node can visit itself using 0 distance, right? True?
Yes.
Fine. Okay, now let's start exploring inside the queue. Inside the queue I am in right now, that is 3. Fine. Front is there, its solid distance is 0. Fine, let's take it out. Now 3 is my front. Tell me one thing. Okay, I can from 3 to 1 I can now at present, if I
बट चाइल्ड भी तो कैलकुलेट करना पड़ेगा ना पहले.
हाँ, तो वो तो लिस्ट में है ना, एडजेसेंसी लिस्ट में तो बैठा हुआ है वो.
ओके
ठीक है. Inside, what is the list of 3? What is the list of 3 right now? 1 5 sorry 1 4 5
2
1 4 5 2. Okay, tell me, can I go from 3 to 1? If I go from 3 to 1, it is costing me already 100. So if I just use this edge, and it will cost me 1. So will it be better for me to go using this edge?
Yes.
By default I haven't gone, so we have kept a maximum value here, that okay, this may cost me 100 at max, not more than that. Fine. So okay, let's utilize this path and take the minimum of both. Take the minimum of 100 and 1 both. Okay, from 3 to 1 I want to go. So if I go using this edge, this is costing me lesser than 100. So okay, let's remove this 100 and take 1 here. Done.
Okay.
Fine. And inside the queue, let us push 1. Pushed. Fine. Now say 3. Okay. What is the next element? 4.
4.
What is, if I Right now it is costing me how much? 100.
100.
Okay, now if I utilize this edge, it will cost me 5. Way
5.
lesser than 100. Let's take the minimum value. Remove this 100. Let's take the minimum value. Done.
Hmm.
Next,
Push.
5. Yeah, push 4 inside the queue. Pushed. Next, take 5. Okay, if I go from 3 to 5, initially
10.
it is costing me 100. But if I utilize this edge as of now, temporarily, if I utilize this 5, it will cost me little bit lesser. From 100, initially it is 100. It is causing me now 10. Let's keep the minimum value 10. Done. Next,
Push.
3 to 2. Okay, yeah. Push 5. Push 5. Now, J,
3 to
I have
2.
to explode 2. Okay.
4.
Similarly, this will cost me 4, right? Already I have fixed a value 100. But if I take this edge, it is causing me way lesser value, 4. So I will take the minimum one. So, okay, at least as of now, after exploring 3, as of now, I can say I can visit this amount of nodes using minimum possible values 1, 4, 5, and 10. Done. 3 can visit itself in 0. Okay. Now, what is the current front? What is the current
1.
front?
1.
1, right? Okay, fine. Where is it? Current front is 1. Take that out. What is the edge of 1? What is the edge of 1?
4.
What is the edge list of 1?
4 and 3.
4 and 3 both. Okay, fine. So let's go ahead with 4. Let's go ahead with 4. Now see. Initially 4 will be seen. Okay, fine. If I go, what is the cost with which I have visited 1? What is the cost with which I have visited 1? It costed me
2.
1. It costed me
1. 1.
It costed me length 1 to visit node 1, right? Exactly 1 is the cost of visiting node 1 from 3. Fine. Now from 1, if I travel to 4, what will be the net cost?
2.
What will be the net cost? No. What will the total cost? 1 has been visited with cost 1, right? Now
2
from
plus
1, I want to
1.
go to 4.
2
From
plus
1,
1,
I
3.
go to 4. So what is the total cost now? 1 plus 2?
3.
1 plus 2 is the total cost of visiting 4 now. Tell me, if I take this path, if from 1 I break my journey to 4 to reach 4, is it costing me lesser than the current cost that I have? Current cost is 5, right?
Yes.
Is it costing me lesser than 5?
Yes.
Okay, so let's update the value. Let's update the value as 3. Done. That okay? Right now, whatever path I have find out, that is costing me way lesser. Initially it was 5. Now I can visit. If I travel using 1, I can visit the same edge using a lesser cost, 3. Fine. This part is done. Next, what should I do? Should I push 5 again? Will it work? कोई जरूरत है?
नहीं.
5 is already inside the queue, right? No need to push it again. Fine. Now next, what shall I do? What is left? Anything else? One can visit in lesser cost. What else is left? 3 is left. 3 is already visited using zero cost. So nothing I can do. If I go from 1 to 3 again, it will cost me how much?
1.
1 is visited with 1. Now I want to go back. So it will cost me 1 again. 2 will be the net cost. So what is the total cost? Which one is better? Shall I go back to 3, or can 3 visit itself using 0 cost? Which one is better?
3 visit itself by 0.
It is already the least cost, right? 0 is already the least cost. So nothing should be done. Okay. One part of 1 is done. Is it? 1 can visit anything else?
No.
Okay, fine. Let's take out our 4. 4 is the current front, right? Right now.
Yes.
Take out 4. Now 4 can visit where?
5.
What is
3.
inside the list of 4? What is inside the list of 4? 3 it
5.
can.
3, 1.
3, 6, 5, right? Nothing and 1. Exactly. 3, 6, 5, and 1.
5.
Let's travel them one by one. Okay. What is the best cost I can reach 6 as of now?
5.
6. For reaching node 6.
Oh, 3, sir. 3.
It is 100, right? I cannot
100.
yet, no path I have found out. From 3, there is no direct path to 6 right now. But right now, if I take a break journey, if I do a break journey, okay, it is initially 3, right?
Yes.
First, we are exploring 3. Sorry for my mistake. We are first exploring 3. So, okay, 3 is already visited using 0 cost. No need to see this. We cannot have a better choice than the initial value. Okay, let's skip that. And now let's start coming to 6. Okay, tell me for 6, what should be the better thing? 100 or what is the net cost that I have visited 4 with? Node 4 has been visited with best cost 3.
3.
So
सर
from
100 कहाँ से आया सर?
100 initial value रख रहे थे ना list का.
Okay sir, okay.
So now tell me what will happen here. What will happen to 6? What is the best cost with which I can visit 6?
3.
From 4 is already visited with cost 3. It will take me at least 3 amount 3 to visit 4 from 3, right? At least it will cost me 3 to visit 4 from node 3. So if I from here, from 4, I require again 3 units to reach 6. So what will be the cost? 3 plus 3. Is it? 3 plus 3. So update the 100 with 6. Because 6 is lower than 100, I will update that. Done. 5. Now 5. Tell me what is it? What is the next?
6 sir.
Okay, with what value I can visit 5? What is the best value with which I can visit 5 from 4? So node 4 has been visited. What is the least cost to visit 4?
6.
Where is it, man? Least cost with which I have visited 4.
3 sir.
3, right? 3. Okay. So what will be the least cost from 3 to visit 5? Right now, the least cost to visit node 5 is 10. So if I break my journey, if I try to visit 5, node 5 from 4, what will be the net cost, total cost?
9.
3 plus 6, right? Least cost to visit
9.
Total cost to visit 4, and from there I want to visit 5. So cost is 9. 3 plus 6, 9. So this was greater value. Update that to 9. That okay? If I do my journey from 4, I can visit my node 5 at a cost 9. Okay. Okay. One thing. This
सर
nodes.
ये वाला लिस्ट फिर से एक्सप्लेन कीजिए ना एक बार.
कौन
3
सा?
से जो
Yes,
अभी ये
sir.
हाँ
चलो ठीक है, करते हैं.
ऐसा समझ में नहीं आया.
बस यही वाला लिस्ट. हाँ.
Okay. What was my in front? Front was 4, right?
4.
And inside the list of 4, what is it?
4 के इसमें आएगा 1
1,
3
3, 6, 5.
6 5.
Yeah. First is this node. Okay. Tell me now, what is the least cost to visit 3? Least cost as of now. 4 पे आने से, 4 को फ्रंट मानने से पहले क्या था? Least cost क्या था?
3.
3, right? So what will be, okay, fine. So I think we haven't visited this node yet. So this will be 100 because we are again starting. Okay, yeah. So first I am having 1. What is the least? 1 पे है really? Okay, yeah.
सर 3 क्यों मानने सर?
Sorry?
सर 3
स्टार्टिंग पॉइंट 3 है इसलिए.
Starting point 3 है ना?
Okay sir. Fine.
So let's see. 1. I is pointing. I will start seeing. I will try to find out least cost of node 1. So what is the least cost with which I have visited 4?
3.
Least 3, right? Now,
Yeah.
if I want to visit node 1, what will be the least cost that I can get? If from 4, if from node 4, I want to go back to node 1 again, what will be the cost?
2.
और 4 पे पहुंचने के लिए कितना कॉस्ट था? What is the cost to reach 4?
3.
Least cost 3. So 3. What will be the net? What will be the net cost to reach 1 again?
Plus 2.
Plus 2, right? So
5.
if I want to go back to 1, from 4, it will cost me 5, but I can already visit node 1 at cost 1, right? So no need to update this. Already I have a better value here. So no need to have a greater value. Okay, let's go back to 3. 3 का बताओ क्या होगा? 3 तो starting node है.
तो अगर 4 से हमको 3 पे जाना है तो फिर
If I want to go to from 4 to 3, what will be the value I should?
3 plus
What will
5.
be the total distance I should cover?
3
I
plus
require
5, 8.
least distance from 3 to 4. Node 3 to node 4. The least path distance is 3. If I go from this node to this here, if I
Plus
go
5.
from 4 to 3 back, I have to add 5 here.
Yes,
5
sir.
more distance I have to cover.
8.
So 8. Already 3 can visit itself at 0 cost. Why should I do that?
Okay.
No need to update. Fine. Now let's come here. Let's come to 6. Now tell me what will happen.
4 से 6 जाना है तो 3 कॉस्ट पे करना पड़ेगा और ऑलरेडी 1 से 4 तक आने का कॉस्ट है 3, तो 3 plus 3 6 हो जाएगा.
Yes, sir.
Is it? Which is it?
तो
6,
6
right?
नोड का
I want to
value
go from
update करेंगे.
4. So what is the cost right now? I am having to visit 4. What is the cost right now? I am
3.
having to visit 4.
3.
3. Fine. Okay. Next.
plus 6 plus 3.
Okay. From 4 to 6, we have distance of
3.
4 to 6, right? Yeah, 3. So total distance I require to reach from node 3 to node 4. Least distance is 3.
6.
Least distance is 3. Now from 4 again, if I go to 6, I will require
3.
again 3 units. So right now, no path is there. No path was explored. So maximum value was stored. Update that to 6 and push
6.
inside the queue 6. Fine. Anything else?
No.
Acha, okay. Now last node is left. 5 is left.
5.
What to do? Now again, what is the least cost to visit 3? 3 was there, right? It was 3.
Yes, sir.
Sorry, yaar. मैं क्या कर रहा हूँ?
Sir, 4 को.
Sorry, what node I am right now?
4.
4,
5.
right?
5. हाँ.
For current front is 4. So I have visited this node. I can visit this node from 3. From node 3, that is my starting point. I can visit this node 4 at least cost 3. Correct?
Yes, sir.
Yes.
So from 4, if I now explore, if I want to go to 5, what will be the cost?
6.
3 plus 6. 3 plus 6. Total distance
9.
from 3 to 5 is coming out to be 9 now, right?
Hmm.
Total distance from 3 to 5 is coming out to be 9 now, right? So right now I can visit node 5 at
By
cost
using
10. Cost 10. So let's update that. I have found a better result. So update that with a minimum 1. 9. Done.
9. Done.
And this was 3. This was 3. Okay, next, what to do? 5 was already inside the queue. Nothing to be done. Next, what should I do?
End हो गया सर.
Okay, हो गया? इतनी जल्दी?
हाँ.
Okay, what
5
is...
पे खत्म होगा.
Okay, what is 5 now? I have to take the front to be 5 now. Front will come out to be 5. Now what it will explore? Least cost with which I can explore 5. Right now
4.
is 9. What is the list of 5? What is kept at the list of
4
5?
and 3.
5 and 4.
4 and
4
3.
and 3, right? Only through 2 things are
Yes,
there.
sir. 3. Sorry, sir. 5.
Okay, so from right now, from 3, if I explore 5, if I to reach from 3 to 5, I require at least cost 9. So again, from 5 to 4, if you want to go back, we will require another 6 element, another 6 units of distance. So what is the total cost? 15.
15.
So I can already visit 4 at cost 3, right? I can already visit 4 node at cost 3. Why to take this path? No need. No need to update. Next.
5
Next.
से 3 पे
I want
जाना
to
है.
go back to 3. From 3, I have visited already 5 at least cost 9. I want to go back to 3. Will it be feasible?
No.
I have to travel 6, 10. So I have to cover 19, distance 19. No point, right? I can already visit my node 3
at cost of
at
0.
least cost 0. Fine. This part is done. Next, what was left? 6.
6 कहाँ से आएगा सर?
Sir,
6
4.
अंदर गया था
हाँ,
ना?
लिस्ट
Yes, sir.
क्यू में है.
लिस्ट 6 तो क्यूब में है ना? अच्छा 2 को हमने
हाँ.
एक्सप्लोर नहीं किया यार. 3 के टाइम में 2 बच गया था.
हाँ.
2 बच गया पर 2 सब कुछ होगा भी नहीं. 2 सिर्फ एक ही जगह जा सकता है 3 पे. तो 2 से कुछ अपडेट होना भी नहीं है, ठीक है। Okay, last node that is left inside our queue is 6.
6.
बताओ क्या होगा?
4
What is the
आएगा।
list of 6? What is the list of 6?
4.
Only
4.
4.
Only 1, 4, right? So what is the cost that required me from 3 to arrive at 6?
6.
6, right? 6 is the minimum cost. Now from 6, I want to go to 4. I want to go to 4. What will be the cost?
3.
3.
3. So will it be, what is the least distance? I can visit 4 at cost 6, cost 3.
Cost 3.
I don't need to visit it using cost 9. Now the cost will be 9. Why to visit this using cost 9? I have already a least distance here, right? Okay, so right now we can see that. Okay, so this part is over. We can see that right now our distance array is storing what is the minimum distance. What is the minimum distance I can visit? What is the minimum distance we require to reach any node from 3, right? Is it correct?
Yes.
Any node from 3. From 3, what is the least distance I require? That will be now stored inside this distance array. Tell me, can you code this? कर सकते हो? 2 कोडिंग है, एक अनवेटेड के लिए, एक वेटेड के लिए। कर सकते हो?
ट्राई करेंगे सर।
Tell me that. Can you do it?
ट्राई करके देखते हैं।
ठीक है, संडे ट्राई करो, नहीं तो मैं अगले वीक बताता हूँ कैसे कोड करते हैं, ठीक है। और मोस्ट एफिशिएंट तरीका क्या है? मोस्ट एफिशिएंट तरीका क्या है? this is a way of finding. This is a way of finding, but this is not a most efficient one. Using queues, we don't have the most efficient part. We require something called priority queues. Priority queues to implement our shortest path algorithm. And this shortest path algorithm is called Dijkstra's algorithm. Dijkstra's algorithm. Single source. Source is 3 and shortest path to all other nodes, right? This is what Dijkstra's algorithm finds. Right? This is what my Dijkstra's algorithm finds. Right now, what we have just explored is modified BFS, shortest path faster algorithm. This is a very efficient algorithm, though very nice algorithm that we can easily learn. Okay, anything else?
No.
Okay, yeah. So let's stop here. Fine. So yeah, let me do the MCQs and we will wrap up today.
Yes.
Okay. Given the first question, please see all of you.
क्या हुआ उसका
I have made the attendance, created the attendance. Please mark all of you. ओके हाँ जुनैद बताओ क्या एरर क्या आ रहा है दिखाना। हमारी आवाज नहीं आ रही है, क्या बात है।
सर देखो स्क्रीन शेयर किया।
देखते हैं क्या एरर आ रहा है दिखाना।
So that error visited j is equal to true. तो मेरा ट्री ये वाला इसमें क्या था मैंने pfs।
ठीक है दिखा देखो विजिटेड इक्वल टू ट्रू कहाँ पर है। अरे वो डबल इक्वल क्यों दे रहे हो, वहाँ पे सिंगल इक्वल टू होगा ना। असाइन कर रहे हो तो फिर डबल इक्वल टू क्यों है। अब रन कराओ।
समझा सर, थैंक यू।
ओके ठीक है।
थैंक यू सर।
या थैंक यू ऑल ऑफ यू। जाओ कल अच्छे से एग्जाम लो पहले, ठीक है। प्रिपेयर वेल, गिव वेल एग्जाम।
Okay, thank you, sir. Good night.
थैंक यू, गुड नाइट।
Thank you, sir.
Good
Good
night.
night.
गुड नाइट।
Good night, sir.
गुड नाइट। अच्छे से देना सौरभ कल एग्जाम,
यस सर।
एकदम फाड़ देना।
पता नहीं, देखा जाएगा, जो होगा सो देखा जाएगा। कोड तो लिख लेंगे कम से कम।
चलो सही। कानू
कोड हो
चला गया।
जाएगा। हाँ
कानू चला गया। अच्छा आप सब एग्जाम दे
कानून
रहे हो
चला
कल।
गया। हाँ हम लोग सब दे रहे हैं।
चलो बढ़िया। सबको देना है ना, मतलब जो भी बैचेस में है, ऐसा नहीं कि पहले दे दिया तो।
हाँ नहीं सभी देंगे।
फाइन फाइन चलो
बट
बढ़िया।
ये थोड़ा सा दिक्कत जाएगा, पता नहीं क्या होगा। कल का सिलेबस बहुत वास्ट है,
ठीक है।
तो देखते हैं क्या आता है क्या नहीं। बस ये कोड तो हो जाता है, मेन दिक्कत ये होती है कि इंटरव्यू वो ये लोग क्या सोच के मार्किंग करते हैं पता नहीं।
तो ठीक है, दो अच्छे से दो, बस यही बात है।
ऐसा
ओके फाइन चलो
आज
नेक्स्ट वीक।
खत्म हो गया डीएस।
नहीं डीएस नहीं, एक टॉपिक बाकी है, दैट इज बैक ट्रैकिंग। फाइन
ओके
ओके एंड वी
यानी
विल
कल
टेक द कोड्स
परसों
आल्सो।
का दिन जाएगा।
हाँ मंडे। एक बात है, पता नहीं कि ये कब होगा, डाउट क्लास पूछते हैं, मैं कल पूछता हूँ डाउट क्लास कब होगा।
ओके,
उसके
अगर
बाद
कल डाउट क्लास रहेगा तो आप उसी में
मोर
लिखना
और
चाहिए।
लेस मैं ट्राई करूंगा कल डाउट क्लास ना लेने का, बिकॉज बट या नोटिफिकेशन ना आए तो सोच लेना कि डाउट हो रहा है डाउट क्लास, बिकॉज तुम एग्जाम देके एग्जॉस्ट हो जाओगे
हाँ
कल का
वो
एग्जाम,
तो,
ये भी बात है। ठीक है, तो
क्योंकि
मैं इस बार कुछ बीपी के प्रॉब्लम्स लेना चाहता हूँ डाउट क्लासेस में,
ओके
एटलीस्ट एक
तो वो
एक वीक
कल
करेंगे।
लेंगे तो ज्यादा बेटर रहेगा।
ठीक है,
मैं कल नहीं, परसों सॉरी।
परसों, हाँ, ताकि लोग आ पाए। ठीक है, आई विल टेक 1 or 2 डीपी प्रॉब्लम्स एंड 1 बीएसटी प्रॉब्लम दिस टाइम। ओके, गुड नाइट ऑल ऑफ यू, जाओ एग्जाम दो कल सही से।
यस सर,
ठीक
थैंक
है
यू
यार,
सो
ऑल द
मच।
बेस्ट।
थैंक यू।
थैंक्स।